Welcome everyone. Welcome at EclipseCon to the first session. I would like to introduce my colleague Maximilian, who will take over the second part of this talk.
Welcome.
And I'm Jonas. We are both working for Eclipse Source. We are a company focused on developing tools for our customers in all different domains. And today we want to talk about a roadmap, or how to develop a roadmap towards web-based tooling. A disclaimer about this talk. EclipseCon has the reputation to be a technical conference with very in-deep technical content, and we love to talk about technology. I mean, we are about building solutions and stuff. However, once in a while there's a technology shift, and going from the desktop to the web when it comes to tools is actually really a shift in the way you develop stuff. It's a major migration. It's not like just deploying Eclipse 5. And when such a migration or technology shift happens, we believe it's of course important to think about technologies and solutions, how to support that, but we also believe it's important to have a good strategy for that. And the talk today is really very much different from the talks that we usually do, where we focus on technology, solutions, how to build stuff. In this talk, we really want to talk about a strategy. We will have some pointers to technical solution, and we will provide some best practices and blueprints. However, this is really, the talk will be on a high level. It should give you some ideas how you develop a strategy and a plan for the next years if you're interested in web-based tooling. This will obviously also contain some generic advice and some truisms. So if you hate truisms and general advice, maybe you want to leave the room now if you're only interested in technical content. Besides that, we hope very much that we can provide you some guidance and some ideas. And maybe you know some of this stuff because it's obvious, but maybe you have some other things that you might think afterwards and which could help you to develop your strategy. Now, quick definition, what is web-based, what is cloud-based? This is not a formal definition, just how we will use it. A web-based tool is basically based on web technologies, so HTML5, JavaScript, TypeScript, CSS. VS Code is formally speaking a web-based tool already. It's running an Electron on the desktop, but it's using web technologies. While cloud-based is then the next step. We deploy a tool in the cloud and access it via a browser, and it's running in a remote scenario. Most of the considerations we do today apply for both, so we kind of use that equally, web-based, cloud-based. It doesn't really matter, and it depends on your project what makes sense most. Many projects go from a local desktop deployed web-based solution like VS Code and then to the cloud subsequently. Now, why do you even want to care about web-based tool? I mean, statistics show that at least 3/4 of all companies do want to migrate some tooling in the cloud in the next years, so it's a very hot topic. There are many, many reasons to do that. The two most obvious ones are that you have a modern UI technology, namely HTML5 and CSS and JavaScript, so you can modernize your UI and the look and feel. And second, the simplified deployment. So ideally, you can just provide a developer with a link and they are ready to go. So those are the main advantages. There are many more, also disadvantages. We will talk about that more in detail. Now, before we start with any advice, let's look at a typical, or let's look at the challenges that we might face when we migrate to the cloud, but also if we start from scratch developing a cloud-based tool. There are two groups of challenges. One is web-based specific. That's due to the technology stack. The typical risks, or the most prominent risks, are compared to the desktop, especially compared to the Eclipse ecosystem on the desktop, there are still fewer components available. If you want to build a tool based on the desktop Eclipse version, there's literally a framework for everything. There's a lot of stuff you can reuse. And the web is catching up. A lot is going on. If you look at all the talks at this conference, a lot of new projects arise, but it's still not at feature parity by far. Second risk is a major technology switch if you developed on the desktop before. So people have to learn TypeScript, they have to learn to work in a remote environment and all this stuff. This might not hit you if you did something similar before, but for a migration project, it is a technology switch. And third, If you look at web technologies, they're much more diverse and volatile compared at least to the Eclipse ecosystem. I mean, the Eclipse platform has been there for 17 years now, or even longer, and it has been very stable. There were few API breaks, and you could very continuously evolve your product. In the web, things are much faster. Like if you look at the UI technologies, Angular, React, Vue.js, how old they are and how often new technologies arise but also go, if you compare that to building a tool which you want to maintain for 5 years, 10 years, 15 years, there's a little bit of a mismatch. So you have to deal with the diversity and the volatility in the web. Now, the second group of risks is more migration specific. That's interesting if you have an existing product on the desktop or an existing tool on the desktop and you want to migrate that to a web-based version. And those are more organizational risks. You have this problem of effort duplication. You're probably not able to just cut all resources from the existing product because you need some maintenance. So you need to deal with, do you have two teams? Do you shift people? How do you deal with that? You have existing customers on the existing product. You want to still serve them with new features, and eventually you want to migrate them, and they have to accept that. Not everybody is fully happy with a web-based solution. And you have this existing tool that you have to maintain, and hopefully you can, at some day, if you migrate, deprecate it, but at least for a while you probably need to maintain both in parallel. Now, let's look at a typical scenario. This is made up, but we have observed this in practice. Luckily, we were not really part of it, but maybe you know a similar situation like this. So imagine you are in the new planning meeting for the web-based migration, and management presents you the plan to migrate to the web. Now the idea is, so those graphs, those lines indicate the features supported in both versions. The blue line is the desktop-based version, and the red line is the web-based version. Now the idea is, we need one more desktop-based release because we're missing some features. We will take 2 months for that, and in 2 months, and that's this line here, in 2 months we switch the complete desktop team to the web version. We don't need anything in the desktop version anymore, nobody needs a new feature, and we will develop the web version, and this is the speed that we are used to from the desktop, so that means in 8 months exactly we have feature parity, we can release the web-based version, and everything is good, and we can immediately deprecate the desktop version. Now I see a few of you smiling. I mean, that's not what will happen. What will likely happen if the plan is like this, and that's also this scenario, is maybe you start like that. So you complete some features in the desktop, and then you start the web development. But what's very likely is that the desktop tool will still demand some maintenance and some features to be added. And maybe you can manage, okay, we put less effort in the desktop and a lot of effort in the web-based tool. But typically you underestimate like how much effort was already spent in the desktop-based tool over the years and how fast you can actually get this to feature parity. And then there's often this break in the middle where people get frustrated about the feature support of the desktop, the web version, and then people are waiting for features, and the web version is not ready. The desktop version is on a low speed, so what might happen is that it is decided to increase the speed on the desktop version again, which lowers the speed on the web version, and as you can see, it deviates, so migration will never happen in this scenario. Now, I mean, this is just an example. Hopefully, in reality, strategy goes differently, but how can we avoid this scenario that something is never completed? So what are mitigations for that? Very important one is to define a minimal viable product, meaning a first increment which you can deploy and which already provides some value. Of course, this is a truism, it's always a good thing in software engineering, but for such a migration is of especially importance. And subsequently, you should try to define increments in which you can step-by-step add new features. What this will prevent is that you have to develop the web-based version for a very long time until you've reached some parity, which should not be the goal. What we suggest is try to find something minimal and already deploy that, cover some use cases with a new version, and then people can already use that, you can get feedback, and so on and so forth. Develop incrementally, which is logic. If you define MVPs in increments, you do that in an incremental process. You deploy stuff, people can use that. This will also help you to onboard two very important groups. One is your development team, especially if they have developed the desktop version before, they have to learn stuff, they have to adapt to the new stack. And the second important group is your users. Like, they have to get used to the new tool, you want to have their feedback, and you step by step want to iterate on your requirements too. And now finally, and last but definitely not least, you should try to reuse as much as possible. And what do you want to reuse is, of course, available technologies. I think that's pretty obvious, but also your own components. And it's surprising how much logic or components of an existing desktop tool you can actually reuse if you find a good architecture for that. And what that has as a consequence, you actually, the red line in the chart before starts much higher. For example, if you have a custom compiler, you don't want to rewrite that for your web-based tool, you want to reuse that. Validation logic, everything which is not closely related to the UI. And even some components which are close to UI, there are patterns to reuse them. And finally, if you find a good way to reuse, you will be able to single source. That means your web version and the desktop version share a lot of code, which will improve your maintenance situation a lot. Because if you fix a bug then in the desktop tool, it automatically applies for the web-based tool and the other way around. Okay, so now what is the first step in this process? The first step is to define an MVP and increments. Like, how do you do that? What you want to do is find the lowest hanging fruit, meaning the use case where you get the most benefit with the lowest effort. And this is really a trivial thing if we look at that, but we have done it several times and really has surprising results. So what we suggest is you look at all the use cases in your tool, and you somehow estimate the benefits. We do that in story points. So I don't know, this use case has 13 benefit, whatever that means, just relatively. And then you estimate the costs as well. What this will tell you, okay, are there use cases with a very high benefit and low cost? Because those are typically the first best MVPs. Those are the use cases to start with. And you can define an order like those use cases I want to do first, and then maybe those with a lower value and the higher effort. Now, how do you evaluate the benefits? Now, we're not talking about benefits of those use cases in general, but benefits of those use cases being available in the cloud or web. Now, to indicate that, you look at the use case and you imagine, okay, if this would be available in the browser, how much would the user benefit from that? The typical advantages are installability, meaning the fact that they can just get started with a workspace clicking one link. Usability, maybe for some users because the UI probably looks nicer. Performance, cost, maintainability, and so on, typically it depends decisions. Like, for example, performance can be better if you have like a super server, but it's also, then it's probably also more important, you will create more costs. Now, there is an article about this specific topic that I've compiled where those non-functional requirements are described, and we have a link, or I can provide you with a link. Anyway, the result of this exercise will be an order of use cases in priority, meaning high benefits, low cost. This is all very abstract. What I want to close with for the first part are three example use cases that we have observed in several projects that are typically low-hanging fruits, meaning a lot of companies that we either work with or that we observe choose those use cases as first use cases to be supported in the web. The first one is the review use case. And actually, this use case has been supported in the web for code since quite a while, with tools like pull requests, Garrett, in almost every source management tool you have online code review. And the reason for that is, it is this typical case. I want to look at another change, so I want to be onboarded as fast as possible because I will only look at this change for, I don't know, 5 minutes or half an hour, so I don't want to set up a full workspace. I have a limited feature set. It's basically reviewing, so I look at the code. It's easy to support that online. So those two combined, installability and limited feature set, very good use case. We observed that this use case is extended from code also to, for example, model-based artifacts that you can review changes on models or other artifacts online. The second use case, also available quite often, is training. So imagine you have, you provide a custom language to program something, and you want to onboard people. They will probably work on this training for, I don't know, an hour or 3 hours. If they can save some time in the installation process, that matters a lot. So you can just provide them a link. You can say, okay, here's an online training. You can fill that in. You can try that out. For that, a web-based tool provides a lot of benefit. And again, we have a limited feature set because the training is like you have defined exercises. You don't need the full power of your toolchain, just a limited feature set. And the third example, which is connected to that, is what we call a playground. Again, the idea is that you can provide a user with a link and they can try your tool, framework, whatever, in a very limited feature set online. So typically, how this looks like is you can select an example, and then you, for example, just have a code editor like here, where a user can modify a bit the example, and then, for example, they can deploy it via a QR code or however the tool looks like. Again, idea is to make the initial onboarding of a user simple. This is typically very popular for marketing because they can show customers the tool within a second just by entering a URL. If you look at the second and the third use cases, they're particularly interesting in terms of benefit because they are targeted at new users. And for new users, installability or the installation process matters the most. So if you provide those things, people are more likely to try your tool and maybe then buy whatever product you want to market with that. So you gain a lot of benefit compared existing users who already use the desktop tools. They initially probably do not benefit that much, but with those examples, you can actually onboard new customers or new users and thereby gain a lot of benefit. Again, with a limited feature set, hopefully you can keep the costs under control. So those are 3 examples we observed in practice, which might provide you a blueprint how to find your good MVP. And with that, I would like to hand over to Maximilian, who will now talk more concretely about methods, how to support this process from a technical point of view.
So welcome again from my side. I agreed to do that presentation, although it's on a very high strategic level, because I could do the second part, which is a little bit more concrete, but the disclaimer still applies. Some of those things might sound like truisms, but those I will try to tell you about examples from real-world projects that I experienced where that really helped us. And what I would like to look into is some methods to help you with actually applying what Jonas said before. So methods to be able to iteratively convert your tool into a web-based version while you don't duplicate the whole development effort and while you keep your desktop tool running, because that's essentially the goal. I'm not going to read those out. In the following slides, we're going to step by step go through the different methods that I have on the slides here. And the first one I would like to start with is backporting. So this is something you can basically apply immediately as soon as you've decided you also want to have a web version. And every time you implement a new feature, it's worthwhile then to think about maybe it is simpler or it's equally simple or almost equally simple to implement that based on web technology. So example that I find quite interesting is if you have some kind of visualization of an analysis result in a modeling tool, for instance. There's a very neat JavaScript library called D3. They have excellent visualizations. If you would like, I would even claim, if you would like to do that in SWT or with GEF, it would be quite difficult to come up with a similar result. So the idea of backporting would be now to say, okay, let's develop that analysis with D3, but then let's take it and just put it in a browser widget within our old tool. So now we have a component that will be compatible with the web version in the future. Still, we can use it in the desktop-based tool. This strategy works for certain features, obviously. It can give you some unique advantages. You have almost no sunk cost. Maybe there's a little bit cost of integrating it for this backport, but usually that's quite minimal. And you have a shared code base, which is a huge advantage. Risks and challenges that can come with those kind of solutions is if you have some kind of user interaction. Let's say you backport that thing, but you need the user to be able to select stuff there, and so the selection needs to propagate within the tool. That gets more complicated. In the example that I just made, that fully paid off in reality for this one example. And even if you just have a selection, it usually pays off as well. You can also still do it. If you have complicated drag and drop, well, then it might become a different story. But that's why it's important to look at those things and then just proactively decide, okay, do I want to do that particular feature in this manner? If you're interested in more examples how you can do backporting, there is an interesting talk by my dear colleague Jonas about modernizing Eclipse RCP applications where this pattern is also applied. It's on Wednesday. Single sourcing, very related to the backporting, also to be applied short term. Basically, the idea is to somehow make sure that you share code between your web-based version for a particular feature and the desktop-based version. The idea obviously is just to share the maintenance cost, and then later on you don't have a migration cost. But it can, of course, lead to an increased development cost. And one example that I find particularly well suited for that is LSP, the Language Server Protocol. I don't know if you're familiar with that, but in a nutshell, the idea is that all the language smarts that you need to create a textual editor to edit a particular language, like Java, for example, you put that in a server, in a headless server component. So this headless server component, for example, can give you auto-completions for a certain location in your text and tell you what is possible methods in terms of Java, for example, that could be used at that particular point. Or it can propose refactorings that are possible at a certain location. Now what you do is you refactor your code so that you put all of that into a language server, and that language server can now suddenly be shared between the web-based version and between the desktop-based version. And if you look at the IDE landscape today, that is what is happening. People create language servers. They have to do the additional effort to write an LSP-enabled client once, but then they can support any language that has a language server. Declarative artifacts, maybe something that's more on the medium term, or when you actually create a new feature. Often you have code, you have a lot of code that does something that you could maybe also extract into a declarative artifact and then write an interpreter that interprets that. An example what we use a lot is forms. So we often write applications that are about data entry. So they have many forms to enter the data for different kinds of entities, and what you usually need to do is you need to arrange that form. You need to create a layout and say this property I enter in this location and that property in that location. That property maybe doesn't even show up. And this process of doing that, you can do that in code, of course, and then you would just write code that is tightly coupled to the UI framework that you're using. So you write SWT code to do that. Or you can invest a little bit more upfront and create a declarative artifact to describe that form, and then write SWT code that takes the declarative artifact describing the form and renders it in SWT. Now, when you do it that way, and you have 100 different forms, then if you want to go to the web, you just need to write the renderer once that interprets the same format, and the 100 forms are in the web. If you would have just written 100 SWT forms, well, then you would have to write 100 HTML5 forms. And for the forms, I mean, just as a side note, seems simple at first, yeah, just write a form. But then there's validation in the form, and there's some rule-based visibility, and then there's maybe a master detail, and it gets more and more, and there's a lot of code that needs to be written. Obviously, there's some challenges with that as well. If you invent that declarative artifact, maybe its expressiveness, or not even maybe, its expressiveness will be lower than code, so maybe some things cannot be done. And of course, you have this initial refactoring cost if you already have the forms to migrate to that new solution. Extracting services, another truism. Everyone says extract services. But what is important in the context of web is that you extract the service to something that's hopefully even deployable as a service. So for example, if you have validation in your tool, can you extract that into a deployable service that can be remote called? Only then it can be really well reused in a web-based scenario. If you can do it, it lowers the migration cost a lot, obviously. So another example is the generator, for example, if you have a code generator. So those kinds of things can often be well extracted into a deployable service. You might even run it in a Java-based JVM while your tool front end is maybe a JavaScript-based, Theia-based solution. Risks, challenges, obviously some things are not so great for that. Talking about validation, if you have live validation and maybe the node is deployed in a remote location with not such a great network connection, maybe not such a great use case, and obviously again the refactoring cost, rather low usually, and in general extracting services is a good architectural pattern anyway, so it will also improve your desktop version. Reuse. As much as possible, think about, can I, instead of implementing that feature from scratch, just reuse an existing component to get this kind of functionality? If you look at all the web-based IDEs these days, many of the things they do, they achieve by just reusing an existing CLI tool. So how is Maven integrated in Theia? Well, there is a couple of UI menu contributions, essentially, right? And then they run Maven on the command line, but it works surprisingly well. Same for many of the Git commands. Some of the Git commands are integrated where there's some value in the UI. Most of them are just CLI. If you talk about scaffolding, why invent something on your own in terms of scaffolding? Rather use something like Yeoman and integrate a CLI into your tool. Because if you do that, then in many cases you can also use it on the web-based side as well. Now, all these methods can be applied at different time frames. What I kind of find important is if you have an existing tool that you would like to migrate, then I find it really important to decide, do you want to migrate and when do you want to migrate, so that you know from which time perspective on you need to take certain decisions. Because if you take that decision that you actually migrate, basically on the next day, when you make an architectural decision, you should already consider that decision. You should already know, okay, we will migrate there. It does not make any sense to write this component in a non-web-based way anymore. So we would rather like to do it in a web-based way and maybe apply backporting to be able to reuse it. On the midterm, you can do things from these methods that I've shown to kind of prepare your architecture in a proactive way, so that while you don't benefit immediately, you already prepare the architecture that later on it will be much simpler to migrate your tool. And as Jonas mentioned earlier, it also helps when you start with high-value use cases, obviously, so you don't wait for the feature parity, you iteratively add high-value use cases that have a value per se, like a review, for example. And finally, you want to end up with single sourcing as many components as possible, because this is not a short process, this is a long-running process. And if you don't single source a component, you just add burden to your development team. And at some point, they won't be able to cope with keeping up with the web-based tool and the desktop-based tool, unless you want to double your development team, right? Long-term, you will iteratively just convert all the use cases and can then at some point deprecate your desktop tool. But that's definitely not a short story for all of the migrations that I've seen. One important point, when you think about that strategy, I find it super important to build a proof of concept. Because every tool is a little bit different, has a little bit of different features, and the proof of concepts makes sure that you discover what shortcomings of the technology that you are going to use are, what weaknesses are there, can they be overcome. It is also a great learning experience for your team, and in the end you can know that it's feasible, and you also get better results in terms of the estimations for a roadmap that you're going to build. I cannot go into depth about those technologies. I've already put the slides online, so I'm not going to read out all the points in here. Here's some pointers to talks about technologies that I consider important when you want to move to a web-based solution. namely Eclipse Theia and Che. There's a talk later about building web-based modeling tools with Theia and Che that supplies you with more details, how to really concretely do it, which technologies to use, how to integrate them. Then there's emf.cloud if you have a modeling tool that's interesting to consider, GLSB if you want to build graphical editors, JSON Forms I mentioned if you're dealing with forms, and many others. So let me just wrap that up. What are, for me, the key takeaways in the projects that we've done so far? First one, I've said so many times, try to do it iteratively. Try to apply the methods that make it possible for you to do it, because otherwise you might just get stuck in the middle. The methods I've proposed on the slides might help you to be able to do that, and kind of as a call of action, what should you do now if you think about those kind of things? Analyze your use cases, try to define a minimal viable product based on your use cases. That can be something like a review, but try to find something that you can actually deploy and not build a roadmap where you need to wait for feature parity until you are able to deploy something. Define a strategy based on those results and then build a proof of concept to make sure that this is actually feasible in the end. And with that, I want to close. Thank you very much. If you have any questions, go ahead.
Are there any questions? So in case you have questions later, maybe you want to think about all that, we are, in all breaks, we are at our booth just in this room outside the door, where it says Eclipse Source, and feel free to talk to us the remaining week. If you have any idea, question, or whatever you want to discuss your particular use case, just drop by and speak to us. And besides that, we are happy if you give us feedback for this talk. In case you liked it, in case you didn't like it, please do not provide feedback. And seriously, about the feedback, there is a comment field there. So if you have any suggestions how we can improve the talk or something that you want to tell us, use the comment field. And it is possible to click a +1 and still put in a comment. And with that, we would like to thank you for the attention. We hope you enjoy the week with all these technical talks about all the topics that we covered today, like really how to do it, how to code that. And we hope that still the strategic overview was useful for you, maybe to select some follow-up topics you're interested in for the rest of the week. And hope to talk to you, and thank you for attending our talk.